So today we're talking about multiples. So you've seen multiples before, so I'll take information from anybody if you have it as to, can you explain what a multiple is? Or can you list me the multiples of 6? Does anybody have any memories of multiples or doing the multiples of 6, how to do it?
I feel like it's like factors, like you multiply. Is it like factors? Like,
Maybe. It isn't factors, or we'd be talking about factors, but I think I'd agree that it's like factors. I think that's fair. The memories or guesses? So let me tell you that one of the multiples of 6 is 6. Another multiple of 6 is 12. Can somebody give me another multiple of 6? 18 is a multiple of 6. 24 is a multiple of 6. 30 is a multiple of 6. And we could do that literally forever. In the homework, it'll usually say, give the first 5 or give the first however many factors of the number. Now that you saw one, can anybody either tell me what you think that's about or do another list?
It's what 6 can multiply into, or like the answers of what?
Change one word and I would agree with you. So multiples are any number or numbers that our number can
become.
6 can do something with all of those numbers. Divide in even. Any numbers that our number is able to divide into evenly. So if I ask you for the multiples of 6, I'm asking you list every number that 6 can divide into evenly. Multiplication can work in 6 times 1, 6 times 2, 6 times 3, 6 times 4, 6 times 5. Multiplying and dividing are kind of the same, kind of opposites. They're related for sure. But if we just go through 6 times 1, 6 times 2, 6 times 3 on down the line, we could list all the multiples that way. You could also list them by just adding the same number over and over again, because remember, adding and multiplying really are the same. Just multiplying is a quicker way to add. The lowest number in every multiple list would always be that number itself. So if I want a list of the multiples of 8, I start with 8, and then just yell numbers.
16, 24, 32,
40, and then I'm running out of space, so I'll just hit up the dot, dot, dot. But yeah, 48 is coming. That's a little bit of what we'll do today. Question about multiples. So are they like factors? They sort of are, because they involve dividing in evenly. The difference is the factors are little, and they can go in. The multiples are big, we're going into them. A memory trick that sometimes helps our 7th graders, factor is a shorter word, just if you count the letters. Factor is a little word, and it's the littler numbers. Multiple is a bigger word, more letters, and it's the bigger numbers. So if I'm talking about 20 and I say 5, I'm talking about a factor or a multiple. Factors are little. If I'm talking about 40, that is
We're not a multiple.
that's a multiple, because 40 is big compared to 20. So we'll change the game, because that didn't go well. If I'm talking about 12, and I say something about 36, 36 is a multiple. If I'm talking about 4 is a factor, because factors are small multiples. If I talked about 12 itself, that's a trick question, because it's both. It's a factor and a multiple. Question about the idea? Second thing we're doing then is LCMs. So memories of LCM.
I know it means lowest common multiple.
It means least or lowest, those are both L words, common multiples. So one way we could do these least common multiple problems is build ourselves a list build ourselves another list, see who's in common, and pick the lowest number that we can find that's in common. So for the lists that we have there, who's in common?
24.
24. So the least common multiple of 6 and 8 would be 24. Don't get this confused with GCFs. Again, they're kind of similar, but they're not really. Again, the factors are always going to be
Bigger.
littler. Multiples are the ones that are the bigger ones. So when we did our GCF homework, most of those answers were like 2, 3, 4, 5, 10. When we do the LCM homework, it could be a little number if the numbers I gave you were pretty little. But the LCMs tend to be more like 20s, 30s, 40s, 100s, however big they go. Okay, your multiples are going to get bigger than where you came in. Usually, the factors are going to go littler than where you came in, usually. Can anybody with words explain what 24 is about that makes it the LCM?
It's, they both have it.
That's true. I'll say it's the smallest number that all of the list divides into evenly. So if I took a thing like this and I just said 144, almost a lot of numbers divide into 144. We did that for extra credit one day. I don't know if anybody found them all, but there were a lot. 144, most things go into 144, but that's not the answer because that's not the, because it's not the smallest. So it's a little bit weird the way it goes. Okay, we're doing least common multiples, so we want lowest number of the numbers that are big. Okay, because multiples tend to be big. Greatest common factor, you want the biggest number out of the ones that are little. So there's a little bit of littleness and bigness to both of those categories. But one way to do that would be to just make the lists and see who's in common, and you go with that. Another way you can do it is just hope your times tables are outstanding and the number just like occurs to you quickly. With 3 and 4, your 3 times tables lead you through a bunch of numbers. Your 4 times tables lead you through a bunch of numbers. What's the first number you hit that they have in common? 12. If that works for you, great. But that's not maybe a good strategy for everyone in the world. So here's another strategy. And this is probably what I would recommend most people to do. It should work for anybody, and it's not as hard as making 2 lists. Just make 1 list. Take the bigger number, make a list for the bigger number. Think about the bigger numbers list until the littler number works. So if we count through the multiples of 4, you get 4, which 3 can't go to 4. Then what's the next multiple of 4? 8. 3 can't do 8. Then you land on 12. 3 can do 12, so we're good. So this one, I think 15 itself, can 10 go into 15? No. So do another 15. 15 and 15 makes 30. Can 10 do 30? Yeah, so we hit it. And you can find them pretty quickly that way. So with 4 and 6, I'd count through all my 6 multiples, because the bigger number is easier to use. Bigger number, count multiples of 6. Sooner or later, 4 cooperates. 12. Question about LCM life. Third thing we're going to do today is a shape kind of thing. There was another day I drew you shapes and we found something. Does anybody remember what we found a couple weeks ago?
The area?
No, we didn't. But you ready for today?
Perimeter.
Perimeter. We found the perimeter a couple weeks ago. How did we do the perimeter of a shape?
So if it's like the same on the sides, then it would be the first number on the side.
Yeah, we fill in all the numbers. So this 2 makes that a 2, this 3 makes that a 3, agreed. And then you add everybody up. Okay, that's what perimeter was about. We're not going to do perimeter today. We're going to do another thing called area. Okay, the perimeter goes around. The area is a measurement of the space inside. So one way you can do the area is if you have 2 this way, separate your shape into 2. If you have 3, whatever, inches, feet, miles, whatever that way, draw yourself like 3 stacks that way, and then you can count them up, and you can come up with 6. Okay, that's not probably the quickest way to do it, but it helps have people understand what we're doing. Basically, when you do area, it's almost like trying to do a count of your tiles you're going to put in your kitchen, okay, or something like that. If there's 2 this way and 3 that way, count them up, you would need 6 tiles to cover that space. So if we had a 3x4 thing, we could go 3 levels. We could separate that into 4 stacks. You count it up, and we'd get 12. You do a couple of those, and you realize you don't need to draw the lines and do the counts. I don't have the patience on this one to make 10 lines this way and 10 lines that way and count them up. What math did we just do on both of those to get the answer? We just multiply. So area, what we're going to always look to do is multiply 2 numbers. You're not going to multiply all the numbers. You just need to know how high is it, how wide is it, multiply them. You're not going to work in this like bonus 2 and bonus 3 that we needed to do for perimeter. We had to find them and add them in. Area doesn't do that. You just need to know how high times how wide and hit it. So this, I didn't draw how wide because it's a square, so all the sides are the same. So there is a bonus 10 there. Total on this
100.
is 100. And then the area for this
28.
is 28. Question about the basic idea of area, I have one other like tidbit to fill in. Question there? What's my other tidbit that I sometimes have done on these shapes that costs you half points? Memories? I can put meters or something on it. So for perimeters, if I put meters on there, you had to make sure you put meters on your answer. For area, you don't do regular meters. You do a different kind of meters. Does anybody know?
Centimeter.
No, we're not going to switch the unit. We're going to make it just a little bit special somehow.
Oh, you put the thing, like you'll put whatever, like if it's meters and you put like the little m beside the number that you get.
No, there's another thing to do as well. Okay, area gets counted with square units. So I need to write square meters on this. There's 2 ways I could write square meters. They both involve an M.
And square.
There's something I could do afterwards. There's something I could squeeze in the middle, and maybe you don't know.
Square. They squeeze
It isn't, but we could do an abbreviation SQ and squeeze that in the middle, and now this is 6 square meters. Or we could do 6 meters and put a little 2 up above the meters. We haven't talked about this year yet. Anybody remember what that's called? A little number up in the sky like that?
To the power?
It's a power, or it's also called an exponent. So we can put a power or an exponent on that. The reason why it's square meters is that all the shapes we counted would have to be squares. We're counting squares. So it's not meters, like this pencil is like 8 inches. That's all it is. We're only measuring it in one direction. But these tiles, I can't tell you that my tile is 8 inches. My tile has 2 sides to it. I would need to tell you that my tiles are like 8-inch squares or 12-inch squares or something like that. These tiles are probably 1 square foot is my guess looking at it. They look like they're 12 by 12s to me. But you're measuring area with square stuff. So if I don't put units on the numbers, just give me an unlabeled number. Don't do this. Does anybody know what that means to do, even though we didn't do it yet?
Times it by 2.
No, it means to do 12 times itself. We don't want to do 12 times itself. We just want 12. But if I go ahead and put centimeters, you need to put the centimeters, and then you have your choice. Would you rather squeeze an SQ in the middle, or would you rather put the little 2 afterwards? I don't care. You do whatever you're going to remember to do. Just put it in the right place. Don't put, let's say I do inches, you do inches, don't do that. That means you want to do 28 times 28. That's not what you mean. You want to double up the inches. Don't do this. I don't know what that means. It doesn't mean anything. If you want to do the SQ, squeeze it in the middle before the inches. So we can do square inches that way or inches squared that way, but the inches is what's getting the stuff. The 28 remains unchanged. So again, if I just do numbers, you just do numbered on label. But if I do a label, you need a label. It's either a little poo or the SQ. Question about what's going on with any of that? We're headed to 2 locations because we did 2 things there. 73 is just a little bit. There's A to D. What the 73 A to D is about is just some areas. They're going to go 4 shapes, do 4 areas on that. The main thing we're going to do in the back is L. And I sometimes wonder if they do this on purpose. L for LCM, I don't know. There's a lot of coincidental things that they do sometimes like that. But set L is all about doing LCMs. Set F was all about factors. Like they do this sometimes, and it just makes me wonder if they're trying to be like cute about it. One day we'll learn about Roman numerals. Do you know any Roman numerals?
Isn't it like 1B? That's like
There's a 1, there's a V.
V is fine.
You know, there's an X. When we do the Roman numeral lesson, they make that set XX. And I sort of wonder if they're doing this on purpose sometimes with their label.
Is it set 20?
Is it set 20 or is it set XX? No one knows.